time do you have? A month? Do you come here every day to work?
Yes.
And are you getting paid? Do you get any stipend? No?
No.
So you have jobs outside of here, or your students? Okay. University students? Okay, can you tell me your majors? What are you studying? Computer science? Software engineering? Okay. IT? Okay. Say that a little bit louder. IT. IT, got it. IT.
I did medicine, but I'm doing a master's in IT. Software engineering.
Okay.
Computer science.
How about
Software engineering.
software engineering?
Software engineering.
Software engineering. I'm doing software engineering.
Software engineering?
Software engineering. Software engineering. Software engineering. Software engineering.
Awesome. So I'm going to ask a couple questions in terms of your age. I'm assuming you're all seniors. Can you raise your hand? A senior, that means this is your last year at the university. Can you raise your hand if it is? Okay. Can you raise your hand if this is your third year, if you're a junior? Okay. One. How about, okay, more people. Good. How about second year? Awesome. Didn't you raise your hand for third year? Okay. Which year are you?
I was for 4 years. So
4 years.
This is third year.
This is what? Your third
Software
year?
engineering takes 4 years. So you're joining third year.
Yeah, so does IT not take 4 years too? IT takes?
IT 3.
Oh, IT takes 3 years. Okay, got it. But I'm assuming you learn how to program, how to make apps in both software engineering and IT, well, not all three, in computer science?
Yes.
Cool, you all know how to make apps. Is it true that you all know how to program in Python? Can you raise your hand if you don't know Python? Everybody knows Python. Okay, can you raise your hand if you know C? Does anybody know C? Okay, but in IT you don't learn C, is that true? Do you learn IT people? Do you guys learn C? Girls, do you learn C? You got C? How about C++?
No.
No C++. Computer scientists, no? Software engineers, no C++? Okay, how about MATLAB? No MATLAB in this world, okay, it's hard. How about LabVIEW? You know what LabVIEW is? How about SQL? It's written SQL. We're good with SQL? Does anybody not know SQL? Maybe first year. Okay. Now, what other programming skills do you have that I have not asked? Now think about all your classes, mainly people who are in the third year IT, fourth year software engineers. Java. Oh, Java, JS. JavaScript. Okay, everybody knows Java. Okay, I learned that 3 years ago. I really want to forget it. Yeah. Assembly, maybe. VHDL. Software engineers. Do you learn anything in VHDL? Verilog, stuff like that? Computer scientists, no? Any database stuff? Okay, so, okay, I did not ask about Java. What else did I not ask about that you did learn in terms of computer stuff? StreamYard? You get
PHP.
PHP, yeah. HTML, PHP, Apache. Right. Yes. Okay. Very good. I did not ask that. Yes. Yes. What else? Do you learn VR stuff? Virtual reality? Unity. Does anybody learn Unity or Unreal? You do learn Unreal, how to program in Unreal? And you're in IT? Say that a little bit louder. Self-taught. Got it. Got it. But you were going to tell me something else that I did not ask that you did learn in your major. I don't know those words. Do you mind writing my notebook so that I learn? Very good. Anything else? Tell me something you guys learned that I did not ask. You must have learned more. You've been studying for what, 16 years?
It's a component of JavaScript.
Right. It goes with Java, but if you don't know JS, you know, you're a step above, right? Does everybody here know JS? Okay, some of you. Okay, got it. How many of you have used an Arduino before? Okay, half of you. Great. You had that in class or is that self-taught? Self-taught. One in class. In IT, you have Arduino in class? Good for IT. Awesome. Okay. Do you put them in? So, okay. There's Arduino and now in IoT. You had an IoT class? Instead of Arduino, did you also, in addition to Arduino, did you also use a Raspberry Pi? What's the other, what is it that I'm not gonna ask? But what's the third sibling in that family? Tell me. ESP? ESP32 is a young sibling, it's just a baby, but before that, yes, another one, then the fourth sibling. So I said Arduino, Raspberry Pi, very good. ESP32, ESP32 has design problems. You used ESP32? Tell me the design problem. What's the fourth one that I'm not saying? It's not that good either, but no? A little bit louder? Yeah, which MC board did you use? Okay, it's a BeagleBone board I was looking for. It's a BBB or BeagleBone Black. It also sucks. So if you tell me that you have learned, if you have used the BeagleBone Black, I'm also going to ask the same question as the ESP32. What's the problem with it? But between the Raspberry Pi and the Arduino, can you tell me the difference? What's the difference, main difference between a Raspberry Pi and an Arduino? IoT people. No? Anybody? No? Okay, so the Arduino, if you're going to measure anything in the world that's analog, you can use an Arduino directly. Raspberry Pi only understands zeros and ones, Turing machine. Everybody here learns Turing machines? Yes? Zeros and ones, Boolean algebra? You had that as IT, software and computer science? Okay, so tell me, if you're gonna build an AND gate, you know what an AND or NAND gate is? You all learned that? AND gate? What's the chip? What's the number for that chip? I'll tell you the two first numbers, 74. All the Boolean algebra, like AND, NAND, OR, XOR, they're all 74, LS, and then two numbers usually. You build things with, you build circuits with those in school? No? Okay, then let's not talk about them. Let's go back to Raspberry Pis. Only understand zeros and ones. Arduinos can get analog signals in and out natively. So with the Raspberry Pi, you still need an analog to digital converter. So I want to pass around something with an Arduino. Unfortunately, I gave away the USB cable, but this here, oh, I have one more question. I realize this is hardware-based, not really what you guys are doing. Most of your projects are app-based or camera. I guess some of you do have camera going there. But, so this here is an Arduino Uno. It's one of the cheapest Arduinos you can buy. The good ones, the good cheap ones cost $20 in the US. But this one I bought for $6. So Illegal is a company that is making spin-offs or cheaper versions of the Arduinos. And this is a project by a second-year student of mine who was going to be a bioengineer and then turned to mechanical engineer and wanted to print his hand and realized the printing was very boring, and now he's going to become a computer or software engineer because he really enjoyed programming the Arduino. I'm going to pass this around. I'd love for you to, if you can be careful, I already destroyed some of these. Wires, but I hope that they stay on the Arduino side because I don't remember where to plug them in. But you can move this hand all you want. This is the size of my student's hand, so some of you guys may have the same size hand. This is super big for me if I put my hand here. It looks like this is a giant hand, but when he puts his hand like this, it's exactly his size. So he modeled and printed his hand according to his. Inside here, you're gonna see it's heavier. There are 4 motors, and when the motors rotates, they pull this wire here to close each. You can pull by hand, but really there are motors under here. And even this one's harder to pull, but it does this. Actually, each finger flexes however much you want, so you can play as much as you want with this. This was printed in a, so how much, do you guys have access to 3D printing? No? Yeah. Yeah, 3D printing is super overrated. I'll tell you what happens. As soon as my students start using 3D printers, they use 3D printers to print things that are useless all the time. So they print like little boxes that you can just go and get a box at the supermarkets. Instead, they want to print it because it's cool, but it takes forever, uses plastic, uses, basically it's bad for climate change. So if you think 3D printing is the thing that you want to do for life, try to make a 3D printer that uses the barker tree. Is it called barker tree in Africa? The tree that the bark is so soft that you can make hats or clothing out of it. I would love to see one of your projects be 3D printer for African purposes with materials that can be recycled. People doing the trash project. I love that one. Just get some of those materials out and make a 3D printer out of it. Would be awesome. But I realize I'm going on and on here. Some how you want? I've been talking already. 10 minutes.
I want to be honest that I missed out on that.
Say that again? You missed out on that. So do you want me to give a talk or would you rather just me talk? I have slides.
It would really depend on what you but I think all models are okay. But did they inform you that most of them are software engineers?
I asked each one of them, and I know IT people,
Okay.
software engineers, computer science. Yes,
Okay.
it's 4th year. IT only has 3 years, so we have 3rd year. 2nd year, there's a couple freshmen, but I don't know if after do you use freshmen, sophomores, junior, and senior? No.
Fresh maybe.
But you don't use this nomenclature. You just say 1st, 2nd, 3rd, and 4th year.
Yeah.
Got it. Yeah. Some of the questions I asked was like American version of the questions.
So I think we could if you could
Sounds
be able to juggle both, it's okay.
Sounds good. Okay. So, good morning, everybody. I'm trying to learn Ringampoli, but it's impossible to say Rirota, Sibriota, Matsibota, DJ, Shaniwe, Wiparimonong, Wiparixima. It's impossible. It's Gaha. And then it's like ego. It's yes, and then they're like, yeah, but you can also just say eh. It's like, really? Just eh. It's like, okay. Just to practice this one letter. It was the hardest letter of my life. So it's like eh. Okay, that was that.
And they're definitely getting you and your colleague. Yeah.
What's that?
One of us, yeah.
So everybody here speaks Ringampoli, yeah?
No.
What? And you're not learning? I'm looking for a teacher, in case you know someone.
This one.
I'd love to learn. To understand the verb. How is it that every verb starts with KU, except when there's a vowel, then there's a KW, and then it's like, okay, what? Anyway, no, very hard. 20 classes of nouns is like beyond my comprehension. And I learned Latin in school. So, I am Brazilian. I was born in Rio, and I was raised in São Paulo. These are the two, I don't know if this will work. It's not gonna work. Okay, so São Paulo and Rio are the two biggest states in Brazil. And since I was a child, I wanted to come to Africa because many of the Brazilian, ancestors were from Africa, or came from Africa, but nobody in Brazil has ever gone to Africa. And I'm assuming nobody here has ever gone to Brazil either, right? So Brazil is not really part of where are we going? In Brazil, also nobody says, I want to go to Africa. like, why not? Because, you know, so this is great. This is my first year here. I'm more than 50 years old, and this is my first time coming to this continent. So I am very, very thankful for the people who are paying, which are the Americans. So it turns out I did all my education in Brazil, and then I applied for jobs, and the jobs there, so I finished my PhD in Brazil. At that point, I had already gone to Germany to study, to Italy with grants from those countries, but I really didn't want to live in Europe. And then I applied everywhere in the world, well, everywhere in my world, in Brazil and in the US, and I got a job at Stanford. And I'm gonna actually go to the next slide. So I started off in Brazil. These are, if you if you ever hear about Brazilian universities, these here are the two biggest and most important universities in Brazil. So I had a bachelor's in electrical engineering, and then I went to Bonn, to Germany, to do a project on retinal implants. So we designed tiny implantable circuits to put inside the eyes of people who are going blind. I can talk more about that if you are ever interested. And then I went back to Brazil and finished my PhD. This is the São Paulo University. And then I applied for jobs. This here, University of Washington, is in Seattle. And then from there I applied to a scientist job, and I got a job at Stanford. And it was not a great experience, so I started applying for other jobs, and I got a job on the other side of the US at George Mason University, and that's where I am to this day. So I've been at this university for 20 years. I am still an electrical engineer, but I started the bioengineering program. I helped them start the computer engineering, and that's one of the reasons I wanted to know if you guys know Python, Java, C, C++, because this is what our students are learning. So our computer engineers, our IT, our computer scientists, they all are trained in Python and C to start with, Java. But then they also learn assembly, VHDL, they can program an FPGA. I'm assuming I think there's only one computer engineer here. Maybe you want to ask yourself if you do know FPGA. And I know fairly well how the curriculum is at this university, but also we compare this university with other US universities. So I'm going to give you only one, I think, example of, I don't know if this will work. I think the audio is probably not going to be too sheesh. Okay, let's see if I can make this work.
Deep brain stimulation is a surgical technique. It's a procedure. What we do is we implant electrodes or wires in the brain in very specific.
Okay, I'll let it run. It's only 2 minutes, but just to explain to you, part of my work is to make, you can't quite see, but there are wires inside this person's brain, and we use this to help people with Parkinson's disease and with epilepsy. So I've worked for many, many years on designing the electrodes to transfer the most charge. So this is definitely an electrical engineering. I apologize to all computer engineers. So most of the computer engineering or computer science goes here, programming the pulses that go inside the person's brain. But I can talk or answer questions in a second about this. Okay, good work.
Areas. We use those wires to deliver a very fine electrical current to those regions of the brain in order to reduce the symptoms and signs of Parkinson's disease and disorders. The electrodes in the brain are connected up to a battery which is implanted under the skin, just below the collarbone in most cases. That battery allows us to deliver a continuous small electrical current to the brain in a very controlled fashion in order to reduce the symptoms and signs of Parkinson's disease and other brain disorders. Despite the fact that it's called deep brain stimulation, in most cases we're not actually stimulating the brain, we're shutting down areas of the brain. By delivering an electrical current which is fairly high frequency current, the nerve cells in the area of the electrode stop working. That allows us to fairly reliably and accurately shut down a small volume of brain around a particular part of the electrode. So even though we're delivering an electrical current, we're actually inhibiting the brain or shutting it down rather than stimulating. Parts of the brain that we're delivering electrical currents are thought to be participating in the circuitry that's involved in Parkinson's disease. So what we're effectively trying to do is disrupt that process by affecting what goes on in one part of the brain. We can influence the pattern of activity in various other parts of the brain, and that can have a positive benefit on their underlying condition.
Are there questions about this video? So I hope you guys saw this patient, this older man shaking. So I don't know if you know anyone. Actually, here it's been very hard for me to find old people. In the US, I don't see as many young people ever. There's a lot of older people, and we see a lot of disease of old age, and Parkinson's is one of them. Alzheimer's is another one. So I don't know if you know anyone with Parkinson's, but what happens is they start shaking or being unable to control only one side of their brain because the other side is being damaged. So if you have a damage on the left side of your brain, usually your right side is the problem or shows the symptoms. So this old man had shaking in his hand, started shaking when the surgeon turned off his stimulator. So we stimulate the brain with pulses, and by stimulating, the brain turns on again or remembers that there is, his side of the body, this side of the body is alive, and then it calms down. Are there questions about this? Are we good? Go ahead.
Well, I see it is a good project, but though I lack some good knowledge about the brain, but I don't know if it is how I was told or I misconceived it, but I think when you
So yeah, nowadays we do implants, but you're correct. Anytime you put things inside your body, did you ever stick a knife in yourself? Maybe not. Okay, I did. But also glass. If you stick something in your skin, what happens is the skin gets tougher. Or, okay, do the girls here have earrings? Does anybody have earrings? Okay. When you take your earring off, do you feel a little tougher part of your ear? Yeah. One of the summers, my group, so you see, I guess you cannot see much, but there's like 15 or 16 students, so probably similar to what you guys have here as a group. And projects that I have supervised are listed. The ones that I have are here. If you go to this website, it's go.gmu.edu/projects. In there's a list of 30 projects. Some of them are similar to the projects that you are doing. Many of them have a hardware counterpart. So this is an example. This is a highlighter that I made them. I wanted them to make me a highlighter that shocks me. Because I have ADHD. So I start reading something and then I need to Google this. I need to do this. I end up never reading anything more than like 2 seconds. Okay, maybe 15 seconds is currently my record. But I wanted them to make a highlighter that if I stop reading, it shocks me so that I go back to reading. And they said, no, nobody likes shock, only you're crazy. So I could not find anybody who liked to be shocked. Does anybody here like to be shocked? No, that's terrible. So I used to put my fingers on in Brazil, the outlet is bigger, so in round, you can put your fingers in there, it's so good. So instead of eating, you can just get shocked. But anyway, they made a highlighter that vibrates if the person stops reading or if the person's going crazy with the highlighter. So it's really a vibrator, but not really. Anyway, a lot of these projects are things that have a hardware component, let's say a table that has solar panels, a fridge that you can put, for example, I'm assuming when you guys make collard greens or the greens that you eat in the summer, you eat lettuce here? I haven't seen any, but like, I'll tell you, carrots go bad if the humidity is higher than something, lower than something, and if the temperature is higher or lower than something. So my students made a fridge with 6 different compartments with a Raspberry Pi. Actually, it's 6 Raspberry Pis, and you can program each compartment to maintain a different kind of vegetable or crop at its best to keep fresh for the longest time. So these are things that they made. So this is a headset to measure the person's brain activity while they are using a virtual reality goggle. So this here is the VR. So we can project VR, we can make them play games, and while they're playing games, we can measure head waves, so brain waves, to see if they're feeling well, if they're feeling tired, if they're feeling sad, stuff like that. You guys have questions? Go ahead. Go right ahead. You like the project? Go on it. So, in my lab, every time somebody's doing a project, I know how you guys all presented. Usually, right after you present your ideas and say, okay, we want to do this, I ask students to put together websites. I don't know if you guys, but it used to be that we put websites on sites, google.com. I mean, you all know how to make a website, right? You don't need to really spend any money, right? It's cost zero. If you have a project, I'm going to suggest you put together a website and start publicizing. Like, give me money. Here's my project. Give me money. Some of my students, so you're going to see there's like more than 30 websites here. A lot of them, not a lot of them, some of them wanted money. So they used a website to say, here's what we're doing. Can you give us some money? So the sustainable fridge one, this year they got $1,000 to make this fridge. And then they went and bought a used fridge from zero. And then they spent almost nothing, and then they popped all the money. Well, they bought Raspberry Pis. The solar panel table they got $10,000 for it. So the other ones, I don't think any of them got money. Oh, maybe the Smart King. The Smart King got $500. So they asked, of course in the US there's more money floating around than here, but if you have websites and you can send me or you can send people or post on LinkedIn profile, can you raise your hand if you have a LinkedIn profile? Do you know what LinkedIn is? Awesome. Awesome. So all of you who have LinkedIn profiles, please connect with me. Here's my LinkedIn profile is this one. This is my LinkedIn profile. Anytime you have a chance to connect on LinkedIn to either your peers, people who are going to probably have job offers for you, or people when you do have a job offer you can reach out to, or people who can, you can take a look at everybody who's connected with me and reach out to them and say, hey, I know Natalia and I see you work with mosquito detection, pest detection, can you help me? That's the kind of stuff, hopefully it will help you. So, now I'm going to give you one example of a project that many of my students made, and it took like 4 years trying the same project. That's the other thing I've seen is that if somebody has an idea and they get started, it's very rare that that idea turns into a startup company or turns into a company. A lot of my students will start one project and then the next year the second group does it, the third group does it, and then it becomes a product, and then it becomes a company. On the student side, the more projects that you are involved with, the better it is. I know one of you guys said you have several projects going on. I love that. I wish all my students did that. It's very hard to do this in America, that students are, oh, let me try this, let me try this, let me try this. But I absolutely think you should do this. So I'm going to show you a video of the second generation of this feeding arm. So this was my first student. Her name is Salma. And she made a robotic arm with like a soldering iron base. And then this here is a popsicle stick. You know popsicle? Is it called popsicle? Ice cream. When you get ice cream on and then it has a stick, that wooden thing. So she got that, and she got tape, and she taped it together, and she could pick up some Cheerios. So these are Cheerios, and you see here the breadboard with all her circuitry. We spent $5 on this. We spent actually just the money to buy the Cheerios. But she said, I'm gonna try to make a robotic arm for $0. It's like, yeah, let's do it. So this is called MVP. Do you learn MVP here? What does MVP stand for? Yeah. Let me hear it. What does MVP stand for? Yeah, anybody in the back there? No? No? Okay. Yeah, I heard you guys. How about in the back? MVP? No? Sankara? So you guys learned it here or somewhere else? Here and somewhere else. So okay, everybody who's here should know what an MVP is. All of us know MVP, huh? You guys know? Girls, you know MVP? No? We'll get there. Okay. Okay. So I'm going to show you a video that follows. I've told my students, if you want to build an airplane, I really need you to start with a paper airplane. And some of them got it, and some of them, but usually in America, really they want to go for this one. And what's the problem with that? So if you start building an airplane and you go for a 747 or a 777, you see the problem with that? What's going to happen? What will happen if you say, no, I really want to build, you know, my first, let's say if you are, whatever, civil engineer, and instead of a little hut with grass roof, you start off by building a hotel. It's your first build. Let's hear what happens.
First of all, you spend a lot of money on an artistic product. So you need to first identify the problems that are associated with the product. You want to identify the users, you want to identify who it's targeted for. So basically that's the minimum viable product if you try to create an MVP first.
Very good, very good.
Challenges before you
Yeah, and you guys did that here? Everybody's on the same page as what he just said? The problems? Yes? Yeah, people in the back, next time you guys have a class, people in the back should sit here. You guys can sit in the back. Yeah, so the second thing is, so there's many issues with trying to build your final product the first time you start building. Even if you know the problems, if you think you know the problems, you know the solutions, you know the materials, it's still doomed to failure. So usually you fail first time. So you should assume every single thing that you ever make will fail. And this is not a reflection of how bad we are. It's just that we're learning. So in the US, people at this point usually give an example of Thomas Jefferson, who discovered the light bulb. Have you heard this example? How many times had he tried before? Do you know the answer? So the guy who made the first light bulb, how many was that the first light, which was the first light bulb? Even people say, oh, he was so smart, he just made a light bulb and it worked. How many? Until he made one that worked. Do you know? How many times did he fail? 90?
Around 600.
600? 680? More. Girls, can I have a number? 10,800? 9,000, okay. That's a good one. We'll go with 9,000. Did you Google it? No, you just, okay, I say 1,000, but sure, 10,000? I doubt it. I usually say, okay, tell me everything that you failed first. So, I'll show you this one, it's a 1 minute video, I think, I hope. So I told them they really had to eat it. To prove that it worked, they had to eat the food, so we'll see. Cerebral palsy, so actually it ended up not in the hospital, but in somebody's house. The dad was a mechanical engineer, and he had to feed his son every day, 3 times a day, and he ended up using this to feed the son. But did everybody understand the video? Hopefully you understood all the failures. I know it's 11:15, and Sankara told me you have to finish by 11:30. I had some more stuff prepared for MVP, but obviously you guys have gone through this. The different steps of engineering design, and the thing of the reason to fail early and often is that, you know, the cost goes up over time and also the value. But if you fail here, it's much cheaper, much faster, much easier to move your project to something that will work at the end. So you really wanna fail here. So, I have the feeling that's the kind of thing you guys learn here in this workshop that I don't really need to talk much. I will put this without audio, but in my lab, one of the projects that also has taken a long time is this is a little robot. This is like a Roomba. I don't know if have you ever seen a Roomba in your life? No? You have? So it's in the US, some people have a robot that cleans the floors like this. But my students wanted to make one that around the lab. So this is where it's walking around is the lab. You're going to see my other students standing there. But this here is a rat brain growing on top of a chip. And the idea is that the rat brain controls the robot. So only the brain of the rat is inside an incubator next to the lab. Yeah, here's my student. So there, but and the robot. Give me an example.
We are lacking maybe around the ESP32 camera,
Yeah.
the boards,
Yes.
the sensors, the motors.
Yes. So, okay. The equipment that you're talking about is small. Small as in, if I had brought, if I had brought this, you're calling this equipment, or what I brought, are you calling equipment? No. Are you calling oscilloscope an equipment? So he's asking, how do you go about getting equipment? In the US, it's super easy. You go on Amazon and you order something, next day it's there. And also there's more money floating around. Like the university will say, I can buy anything that's $500. So the ESP is $10. Actually, right now I think the ESP32 is $15 for 3. I can buy it. The very, very expensive stuff I can't. Of course, like an MRI machine. Nobody has an MRI, but are you asking an ESP32 or are you asking an MRI machine? ESP32, okay. And I understand here you can't order an ESP32, is that true? Yeah. So this is the same as in Brazil, and what happens is when I go to Brazil, I put a lot of stuff in my suitcase that people want, so it takes a while. But if you know people who are coming to Uganda, I can send stuff, in their suitcase. So I came with 50 pounds of materials to donate to the university. And I can't remember if I brought the ESP32. So for example, right now I have ESP32s in my house. If you want, I can have my daughter mail them to us. But I don't know how to fix this problem from a Uganda perspective. I feel like Uganda needs to allow people to ship things here without forcing tariffs on it. Is that if you try to buy something from another country, you have to pay 100% price on the tax? And that is, does it depend on the thing?
Depending on the price.
Is there any, depending on the price?
Yeah.
So you can buy a $20 thing and you're going to pay 0?
Yes. Yeah.
Really? So let's try. From here, I could order from the US for $20 and they can ship it for free? Not ship it for free. You can get here for free.
It depends on the shipping company.
I'm going to try. So I have, in the US it costs 0 for me to ship. I'm going to see if it costs 0 to ship here, and then I'll let you know. But I agree, I think it's a problem. But in Brazil, the reason Brazilians do this is to increase the innovation in the country. So instead of buying an ESP32, maybe you want to buy just the microcontroller, just the chip, and make your own board. So have you ever made the printed circuit board in your life? Okay, I made from scratch, but I learned in Brazil. In the US, nobody makes printed circuit boards by hand. In Brazil, we don't have machines that make printed circuit boards, so I bought acid and I bought a printer. So I've seen a couple printers here, like a laser printer. I put a glossy paper. Do you know glossy versus matte paper? Do you have glossy paper in Uganda? Do you know what glossy paper is like for photographs? What happens is, if you put a glossy paper in the printer, the ink doesn't like that glossy paper, so it stays there. But if you put your finger, it smudges. So you don't put your finger. So you get a glossy paper, you printed the circuit on it, and then you get the copper board that is for printed circuit board, and you put on it, and then you turn it up. Here's the paper, and you iron it. So when you iron, it transfers the circuit from the paper to the copper. And now you have copper with ink on it. And this gets etched, and then this I put in acid. And the acid eats away all the copper that's not protected by ink. Is this too hard? Or are you following me more or less? I can send you a way to make it cost me $2 because the copper board costs me $2, but I don't know if you can get copper board in Uganda. You can? No? I have to ship you the copper board then. And then you make your own ESP32. But I realized maybe you want to ask an electrical engineer to do that for you. So, but computer engineers have an easier time because you can do stuff on the computer, right? Are there software packages that you cannot buy? They're all free, what you use, right? Yeah. Unreal is free?
Yes.
Yeah, Unity is free if you don't need to use the asset store. So we got Unity for free, but how much, did you program a lot in Unreal?
It was more a fun kind of thing, but I paid around $75.
You paid $75. That's a lot of money. Did you make money with it? So in my lab, I had 2 students play with Unreal and Unity. Both of them were hired by companies that wanted them to program, video games, so video game companies. And they made small video games, and they also made those websites that I told you about, and then these companies said, oh, these are very cool games, you want to come work for us? And then I lost 2 students. Very unfortunate. So, other questions? Any questions? No questions.
Questions really?
Any personal questions? Like, I have a cat. I know people who don't have cats.
Prof, do you mind sharing a few? There's an open disease that you know.
Open what?
Like those macho,
Yeah. I'm gonna look it up at home. Wait, about for a small business we're talking, Sakara? Or for projects, for undergraduate projects?
I think what tech innovations, because here in Uganda it's really hard. You're not going to find someone that you sit with, explain your concept to, and they say, okay, here is a few millions for you. So
Yes.
Especially just
Okay,
idea.
but for you, I can make a list specifically for you, but maybe for them to pitch their projects. I'm gonna look it up, but, so in my university, there is like, something called pitch IT. For that question, Zakara, but I promise you, I'm gonna go look up where you guys can pitch your projects for money. But in the car, I was telling you something more specific. What was it?
the visit you're about to go to?
Yes, yes, of course, skiing. So this here is not for students, I don't think, but it's the curve, like, mindset, it's entrepreneurial mindset. So they support small projects, 5 to 10,000, and I think $10K. And I think this can be international. So we should, I'll absolutely go try this, but the Gates Foundation has funded it. Somebody told me in the US, a lot of these things are going down. The Gates Foundation says they are not going to fund as many projects anymore. So the key people are not for students, I think it's for academics and professionals. But then these pitch competitions are very small. $5,000 to $10,000 for the US is very small, but they give between $500 and $10,000 prize for people who win these competitions. So it turns out my daughter won with I know one of the groups who came here said, I'll tell you, student security. The group that had 2 people here, the first one of you said, you are 5 students. You're doing student security on campus. Can you raise your hand if you were doing that one? Yeah. So my daughter's project was a little circuit to put on the shoes of girls, or I guess boys too, to walk around campus. So in the US, there is a problem of raping or sexual assault on campuses. And it turns out the first 3 months of freshman year is the 3 months where there's the highest number of rapes of girls, or sexual assault of girls. It's more than rape. Sometimes it's just an attempt. And many girls are now having something on their keychain that's an alarm. So if they feel threatened, it's almost exactly what you said, but they don't yell, they press this thing and this thing buzzes, because sometimes.
The mobile application also has a panic button, yeah?
But then you have to turn the phone on. So people know about the phone and about yelling. So they will do this and not let them. And then apparently even the one on the keychain, the girl said, well, but then they're holding our hands. So if with one hand you can hold two hands, right? So a guy could hold my two hands and then put, and also if anybody screams in the US, nobody cares. But anyway, so with your hands, if your hands are tied, what do? And they put, I know I'm saying this word all the time. If you don't understand what do you understand the word accelerometer? Do you understand what this word means? No? So an accelerometer is, you know, airbags in the car? The airbags get deployed if there's a crash. And the way we detect a crash is it's like this. Can I use this for a second? So it's like this. We make a tiny chip, of course, but it's like a bridge that's cut on one side, so it's a lever like this. And if I move a little bit, it's like this. But if I crash, do you see how the other end of this moves a lot? We put a floor here that's conductive. So if this hits here, this is the on-off switch. So an accelerometer deploys your airbags in the car in case there is a huge crash, because it's like this. It's a small crash. When you really crash, like crazy, not you, but the car crashes, it turns on like this. So she used this this is tiny, of course. She used this to make her little circuit. And if the person stomps or kicks, the alarm goes off, and then it sends a text message to the police, to whatever. So they got several prizes. They got like $10,000. They used like $10 to make this device. They got $10,000. So this is the kind of project that in the US can be done. I don't know if they're going to make a company. They're trying now to start a company, and they only have like 3 prototypes. I told them you have to fail another 100 times to make it work. But now their company's trying to buy their ideas. So this is the kind of thing I hope, if you can advertise your projects in the US, you can get some money. Maybe you can get stuff made there, but then get Africans to benefit from your ideas. But yeah, the campus. Go ahead.
I think the problem is not. The problem is actually how to reach out.